For this analysis scenario, data has been collected from countries across the world. However, fixed broadband internet usage values are currently unavailable for most African countries, which are represented on the map chart in red. In preparation for this analysis, the countries which do have reported broadband values were randomly partitioned into training data and validation data subsets, which are represented on the map in blue and green, respectively. Our goal is to use the reported data to fit a model, evaluate the model, and ultimately predict the broadband usage values in the unreported countries. Our first step will be to fit the model. We'll begin by going to Tools, Regression Modeling. We'll name our model something like MyModel01 and type a comment like, assumes parametric statistical methods can be applied. We will use the linear regression model method, and we'll apply this method to the data table where the training countries have been isolated. Then we'll indicate that our response column is fixed broadband internet subscribers. For the predictor columns, we'll select all of the remaining numerical columns, which describe various aspects of each country. In this example, we expect the relationship between these values and the broadband usage to be linear in nature. However, if you expect relationships between predictor and response columns to be something other than linear, you have a list of options available. We'll leave this selection set to linear and click the Add button. You can see that the values have been added to a formula which defines the model. This formula may be edited later, as we may wish to iteratively adjust the model in an effort to achieve a better fit. And under the Options tab, you have the ability to further modify the model by indicating a weights column, which contains values which are to be applied in order to increase or decrease the relative importance of the values on specific rows by multiplication with the value in the weight column. We will not include a weights column, and we will not make any adjustments to the formula expression. Instead, we will click OK and examine the results which are returned from the TIBCO Enterprise Runtime for R statistical engine. On the resulting model page, you can view the summary metrics in the Model Summary panel. You may wish to focus upon the magnitude of the residual standard error, the R-squared values, and the p-value. Low standard errors and p-values, and R-squared values close to 1 are desirable. For this model method, a table of coefficients is displayed. The y-intercept and slope for each predictor are presented in this table. In addition, p-values for each predictor are available. Lower p-values suggest that the associated variables are significant or important in the model, so you may wish to sort the table accordingly. In addition to these measures, several diagnostic visualizations are available. The variable importance plot is another measure where you can see where the predictor columns we selected ranked in order of the relative importance regarding their impact on the magnitude of the broadband usage value. Note that the number of telephone lines is ranked with the greatest importance, and the cost to import and export are relatively the least important predictors in the model. The residuals versus fitted plot is another diagnostic visualization which has been created by default, so we do not have to click on this link. What we are looking for here are patterns. Ideally, we would see no patterns. Instead, the residuals would be randomly distributed with a constant variance centered around 0. This data seems to suggest the model suits the data reasonably well. The normal quantile-quantile visualization is sometimes called a QQ or normal QQ plot. The purpose of this plot is to allow you to check for departure from normality. Due to the fact that these values fall in line along the diagonal, we can take comfort in the fact that these values are normally distributed. The scale location visualization, which is also known as a spread location plot, is similar to the residuals versus fitted plot, but it uses the square root of the standardized residuals. As with the residuals versus fitted plot, no pattern is a good thing. Instead, random distribution is the goal. Cook's distance is a statistic that tries to identify points which have more influence than other points. Generally, these are points that are distant from other points in the data, either for the dependent variable or for one or more independent variables. Each observation is represented as a bar, whose height is indicative of the value of Cook's distance for that observation. There are no hard and fast rules for interpreting Cook's distance, but larger values represent points which have more influence than others on the estimated coefficients and might require further investigation. Finally, let's view the response versus fitted visualization. you can see that our result follows the appropriate trend, which is for data points to appear along a line with an intercept of 0 and a slope of 1. Even though this model seems to fit pretty good, let's see if another model method might be more instructive. We can return to Tools, Regression Modeling, name this model MyModel02, type a comment like Applies non-parametric statistical methods, and select the regression tree model method. Again, we'll focus on the training countries data table and select the same columns to serve as our response and predictor columns. When we click OK, the resulting model summary defines the tree object, which represents the series of splits, beginning with the root, and the subsequent splits, which reflect the node, split, number of observations, and mean response value for that subset. The final nodes or leaves are indicated by asterisks. Scrolling down provides additional metrics which will help you examine the partitioning of response variables based on your chosen predictor variables. 2 of the 3 available diagnostic visualizations are already displayed: a plot of residuals versus fitted values and a variable importance plot. You also have the ability to display response versus fitted values. Note that the fitted values correspond to each of the terminal nodes or leaves of the tree. Note that if we were to continue making iterative adjustments to these models in an effort to achieve a better fit, this icon within either of the model summary title bars would allow us to duplicate the model such that we could use this icon to edit one of the copies and adjust settings like the selection of predictor columns, the relation of those values to the response column, which is currently linear, or include a column which serves as a weighting factor for specific data rows. Instead of trying other settings to achieve a better model fit, we will return to the country partitioning page and use the View menu to launch the Analytic Models panel, which allows us to see information from both of our current models. We will use this icon in order to evaluate the linear regression model. We will select our validation countries data table and note that all columns are named the same as our training data table. Otherwise, we would have to match the response column and the predictor columns to the corresponding names in this new data table. When we click OK, we have an opportunity to examine how the model fits the new data. In the evaluation summary panel, the R-squared value will approach 1 as the model approaches being a perfect fit, and the sum of squares error shows the magnitude of the differences between the observed response and the predicted values from the model. The residuals versus predicted plot can be evaluated much like the residuals versus fitted plot, and the response versus predicted plot should be evaluated just as you did the response versus fitted plot. You can see here that at least one value was not predicted well by the model. The normal QQ plot will show that the distribution is close to what would be expected by a normal distribution, but does not completely conform, again due to that one outlier. Let's evaluate the other model, which we could do by viewing the Analytic Models panel, or returning to the page with the model summary for the application of the regression tree model type. We'll click on this icon and select the validation countries data table. Again, after checking that the response and predictor columns are appropriately matched, we can click OK. For this evaluation, we are provided with only the response versus predicted and residuals versus predicted plots as diagnostic visualizations. In addition, we could examine the evaluation summary metrics and note that the R-squared value and the sum of squares error both suggest that this model does not fit the data as well as our first model. Therefore, let's declare MyModel1 as the winner and use it to generate predicted data. We could launch that prediction from the Model Summary title bar, from the main menu Insert Predicted Columns, or from the Analytic Models panel. We'll select the data table titled Broadband Unreported, and note that the Consumer Price Index column from the model does not match this data table. If we select the column manually, we can see that the column name was abbreviated CPI. After we click OK, you can see the predicted column containing values for the expected fixed broadband internet usage in those countries has been added to the unreported data table. We can also view the Filters panel and scroll down to see the range of values displayed for that predicted column. While here, we might right-click to rename the column with a more appropriate title, or proceed to examine the results generated by fitting the model, evaluating the model, and predicting from the model. Using the interactive visual analytics environment, which is right at our fingertips.